In this CSEC problem, we have a circular drain pipe that's 1 meter long and has outer and inner radii of 20 centimeters and 15 centimeters respectively. We'll want to draw a cross-sectional view of the drain pipe and calculate the area of that cross-section and the amount of material needed to make the drain pipe. So let's start by looking at the first part, finding the cross-sectional or drawing that cross-sectional view. Now remember that the cross-section is wherever we can cut that will be parallel to the base. So this would possibly be the cross-section, right? Since it's parallel and identical to the base, okay, that means it's going to be the same cross-section, which is going to be like the face of right here. So if I draw that like this, so it's not the best circle, but I tried, then it's going to be our circle here. So this would be our cross section, and we're showing the measurement of the inner and outer radii. So the inner radius is the radius of the inner circle, so the inner radius is 15 centimeters, and the outer radius is the radius of the outside circle, so that would be the 20 centimeters. So this would be our cross-sectional view. Next, we want to calculate the area in square centimeters of the cross section of the drain pipe. So since we already have the cross section, we're basically finding the area of this. We could say that it's a compound shape. If you think about it, this area, this is the only part that has stuff, right? This is the actual pipe. In here is just empty space. So the area of this cross section is kind of like we're saying we have a big circle and we're taking this empty space out of the middle. So we're taking a little circle out of the middle of that big circle. So the area of the cross section, okay, is going to be equal to the area of the outer circle minus the area of the inner circle. Kind of like what we're seeing here. So remember that the area of a circle is equal to pi r squared. Let me just write that down right here. And we are using pi to be equal to 3.14. So the area of the outer circle is going to be equal to pi 3.14 times r squared, the radius of the outer circle, which is 20. So that's 20 squared. If I throw that into my calculator here, okay, then 3.14 times 20 squared is equal to 1,256. So that's the area of the outer circle. So 1,256 square centimeters, that is. Next, the area of the inner circle is equal to 3.14 times the inner radius, which is 15 centimeters. So that's times 15 squared. And 3.14 times 15 squared is equal to 706.5 square centimeters. Okay. So that means the area of the cross section is going to be equal to the area of the outer, which is 1256, minus the area of the inner, which is 706.5 square centimeters. And if I work that out, then 1256 minus 706.5 is equal to 549.5 square centimeters. So that's the area of our cross section. So we've drawn the cross section, we figured out the area of it, and now we want to figure out the amount in cubic centimeters of the material required to construct the drain pipe. All right. Now, I know you're probably thinking to jump onto your formula for the area of a cylinder, but this isn't a regular cylinder, right? Because it has this big hole in the middle. So even though we are not going to use the formula V equals pi r squared h, we've done a lot of the work already because we already know the area of the base or the area of the cross section. Remember that it's coming from the idea that the volume is equal to the area of the base or cross section times the length. And we already know the area, and the question tells us the length. The length is 1 meter long. So that means if I want to figure out the amount of material for the drain pipe, it's going to be its volume, which is equal to the area of the cross section, which is 545.9 square centimeters, times the length of the drain pipe. Now remember, we want our result in cubic centimeters. I already have 549.5 in square centimeters, sorry. So now I need to convert my length. Remember earlier we said that the length is 1 meter long. So I need to change 1 meter to centimeters, okay? 1 meter, what do we know? We know that 1 meter is 100 centimeters. So that's going to be 549.5 times 100, okay? And when I'm multiplying by 100, it's kind of like thinking that you're moving the decimal point 2 places forward. So that's 1, 2. So my answer would be 5495 and then one more 0. So 54,950 cubic centimeters. Therefore, the amount of material required to construct the drain pipe is 54,950 cubic centimeters.